Hello dear students and welcome to today's lessons in World Regional Geography. In the previous class, we learnt about ethnic races and traditional vocations in Asia. Today we shall learn about weather patterns and climate in Asia. We will thus touch upon zones and latitudes bearing significance for weather in Asia, how terrain influences weather in various parts of Asia, the phenomenon of monsoons around the Indian Ocean, the challenge to climate in Asia, we talk about climate change and Asia, and repercussions of El Nino and La Nina in Asia. Let's start with zones and latitudes that bear significance for weather in Asia. By understanding the latitudes and the influence they bear on weather systems, we will be able to understand why certain weather patterns are unique to certain regions. Longitudes that run north to south on the planet Earth are an indication and measure of the daylight that occurs in a region. Longitudes help us in understanding vertical separation of certain areas or regions. It also serves as a timeline and dateline. Latitudes, on the other hand, serve as horizontal bands enveloping weather in a region. Latitudes help us understand how weather is dependent on sunlight, precipitation, condensation of moisture, humidity, and ground frost. We also need to understand other factors that influence weather patterns. Altitude above mean sea level and influence of the ocean currents are also significant factors. Areas which last endured the last ice age are still lingering from its after effects. It is in such areas where the last ice age spread that today the snowfall thrives when temperatures fall. During the course of this lecture, we will understand how weather systems play a very significant role in our lives. The latitudes on the planet are an indication of the amount of sunlight that falls in that entire belt at a given time of the day. The higher latitudes and the lower latitudes indicate that much distance from the equator and indicate a lessening of sunlight. Asia, being the largest landmass, extends well over 100 longitudes and around 86 latitudes. The area between the equator and the Tropic of Cancer lies in the tropical belt, receiving ample amount of sunshine. This belt of Asia enjoys balmy, somewhat constant yet mild weather all year round. This is in contrast to the very harsh variables in the temperate north. The area between Tropic of Cancer and the Arctic Circle is the temperate zone and is characterized by very harsh extremes of weather. The temperate zone enjoys 4 distinct seasons. These are summer, winter, autumn, and spring. Rainfall is recorded for much of the year and there is no monsoon period. The major controlling factor over the monsoon climate is its relationship to the monsoon circulation. Recall that the monsoon is a seasonal change in wind direction. The classic monsoon circulation of Asia exhibits an onshore flow of air, that is, air moving from ocean towards land during the summer or high sun season, and offshore air flow, that is, air moving from land towards water during the winter or the low sun season. The change in direction is due to the difference in the way water and land heat up. Tropical Asia includes the southern landmass of the Indian subcontinent, the tectonic plates of Indochina and the Sunda Plate, the equatorial archipelagos including Indonesia, Papua New Guinea, Taiwan, Spratly Islands, Philippines and Borneo, the land west of the River Indus and the Hindu Kush Mountains, geologically speaking, belongs to the Eurasian Plate. Thus, in the tropical belt of Asia, we may count South India, southern Myanmar, Sri Lanka and Maldives of the Indian subcontinent. Additionally, Thailand, Malaysia, Singapore, Cambodia, Vietnam, Indonesia, Borneo, Philippines and southern Taiwan belong to the tropical belt. North India, Pakistan, Nepal, Bhutan, Bangladesh, northern and interior Myanmar belong to the temperate zone. North of the Indian subcontinent, the countries of China, Mongolia, Kazakhstan, Turkmenistan, Kyrgyzstan, Uzbekistan, Asian part of Russia, North and South Korea, northern Taiwan, Japan all belong to the temperate zone. The Tropic of Cancer cuts through Taiwan right at the center. Thus, northern Taiwan is in the temperate zone and southern Taiwan is tropical, much like India. Though the Middle Eastern countries of Saudi Arabia, Iran, Iraq, United Arab Emirates, Sultanate of Oman, Qatar, Yemen, Kuwait also hug the Indian Ocean, they are not influenced by the monsoons. Why? That is partially because these countries are placed geologically on the Eurasian tectonic plate. Besides, the desert conditions, full with rocks and sand dunes, are more conducive to blowing winds and storms than to tropical moisture-laden clouds and winds. Lastly, the vegetation and the biodiversity do not act as catchment area for the monsoon-bearing clouds, which bring in the monsoons. Strange indeed, because the root of the word monsoon is Arabic. The sunshine that obtains in the tropics accounts for snow melt and snow-fed rivers that water the fertile plains and agricultural areas of large parts of Asia. In the temperate parts of Asia, the weather is so severe that there is only freezing and thawing, which limits the scope of agricultural growth. In the temperate zone, nevertheless, there is significant agricultural produce. They do account for the export of wheat, maize, vegetables, fruits, animal products like meat and milk products, hide and eggs, etc. People in the temperate zones are thus used to obtaining their carbohydrate intake more from potatoes than from rice. We have studied enough about agrometeorological traditions in the last few chapters. It now makes sense to understand why the people of the Arctic Circle are used to hunting and eating whale meat and make costumes with hide and blubber, isn't it? Obviously, one would say, they wouldn't be very comfortable wearing cotton clothing and eating rice with vegetable curries to beat the harsh weather conditions of the polar regions. In the tropics, the precipitation of the rivers or evaporation accounts for the cyclical monsoons, which in turn feed many river systems of Asia. This time-tested cycle of Mother Nature has blessed the people of Asia with an agricultural diversity unrivaled. Tropical Asia enjoys balmy weather ideally suited for production of the agricultural diversity that man is blessed with. Nearly all the rice production of the world can be traced to the tropical countries of Asia. China, India, Thailand and Philippines are the largest producers and exporters of rice. Besides rice, Asia offers bountiful harvests of wheat, maize, corn, barley, lentils and pulses, millets, spices, fruits and vegetables, flowers, orchids, nuts and berries, coffee and tea, sugarcane, cotton, jute, hemp, silk, rubber, freshwater and marine fisheries, milk and milk products, timber logging, among others. China has bagged a large share of trade in rice thanks to her industrious populace, intensive farming methods and political economy. In fact, China has become the world's biggest exporter of rice in the last decade, overtaking the rice export leadership from Thailand and Philippines. How do we explain the dichotomy that China is the world's largest rice exporter when the country wholly lies in the temperate zone? The ground frost alone is utterly untenable for rice cultivation. In fact, China has a shortage of arable land thanks to mountain chains, valleys, deserts, floodplains of rivers and her rivers that constantly change course. Not all pockets of China can afford surplus production of rice. The answer lies in the fact that China, like India, is also a kind of a subcontinent with very rich soil diversity and generously irrigated by her vast river systems. More significantly, the cooperative farming methods and political distribution of economic resources in a collective cooperative framework accounts for surplus production. It is the same political mechanism that explains surplus rice production, increase in export of rice and increase in food grain production. How terrain influences weather in various parts of Asia. In a previous lecture, we have learned how terrain influences vegetation. Similarly, terrain also influences weather conditions. Let us learn this with the aid of examples. The Himalayan mountains take birth in the Pamir northeast of Afghanistan and stretch all the way till northern Vietnam. This mountain chain effectively separates tropical Asia from the temperate zone. The mountain chain is the birthing suite for many river systems, including Ganges, Brahmaputra, Indus, Yamuna, Hongho, Yangtze-Kiang, Tsangpo, Mekong, among other dozens of smaller rivers. All these rivers are snow-fed but flow down to the tropical plains, supporting fertile alluvial soil and vast tracts of arable land. The mountain chains offer a wall protecting the tropics from the cold winds of the grasslands north of the Pamir Knot. The snow-clad mountains of Himalayas and Tibet melt to feed the Himalayan rivers of Ganges, Brahmaputra, Indus, Yamuna, Hongho, Yangtze-Kiang, Tsangpo and Mekong. These rivers carry with them not just alluvial soil but also generous supplies of mineral deposits. The floodplains of these rivers and the tracts watered by the changing course of these rivers support a diverse biological and zoological diversity. These features support natural features like wet evergreen rainforests, submontane forests, mangrove forests, grasslands, deciduous forests, shrub forests, etc. These biomes in turn act as catchment area and also as a sponge for the humidity. Without the catchment area, rainfall patterns would be affected, and that leads to a cog in the climate change cycle. The Himalayan mountains are the barricade for the southwest monsoon clouds that circulate over the Indian Ocean and head inland towards the landmass in tropical Asia. When the monsoon-laden clouds hit the mountains, the clouds burst into rain, soaking the Indian subcontinent in the spectacular monsoons. The spectacle of the southwest monsoon winds turning westward after hitting the Himalayas accounts for the spread of the monsoons across the Indo-Gangetic fertile plains. The westward progress of the monsoons is halted after the clouds clash with the Suleiman mountain range of the Hindu Kush fold mountains in Afghanistan. The westward progress of the monsoon clouds corresponds to the rainfall pattern. Before this cataclysmic clash of the cores, there is unsurpassed humidity on the landmass in the subcontinent. The heat and dust of the pre-monsoon summer is appropriately cooled down by the monsoonal rains. Ironically, the fury of the southwest monsoons drenches North India thanks to the natural barricade of the Himalayan peaks, and the northeast monsoons lash large parts of South India. When the southwest monsoons arrive in the subcontinent, they clash first with the western Ghats, soaking the mountain ridges on India's west coast in monsoon. The rains sustain the wet evergreen-rich rainforests on the western Ghats. The biodiversity hotspot thrives with its rich and unique flora and fauna. The intensity of the southwest monsoons is felt best on India's west coast. After unleashing its moisture burden on the western Ghats, the clouds progress inland in a northeastern direction, gathering moisture from the catchment area in the Deccan Plateau. When the rain-bearing clouds cast their spell on peninsular India, it lacks the same density of moisture content. That is because the monsoon clouds have to replenish their moisture content as they head towards the northeast to collide against the Himalayas. The catchment areas for moisture accumulation are the Vindhyas, Satpuras and Aravalli hill ranges. By the end of June, the monsoon clouds clash against the Himalayan peaks. It is part of Mother Nature's grand cycle. In fact, the hinterland of peninsular India is largely a rain shadow area for the southwest monsoon. Peninsular India gets the rains from northeast monsoons. The lower Himalayas in northeast India receive the highest rainfall year-round because the area receives both southwest and northeast monsoons. Cherrapunji on Assam-Meghalaya border in India is the spot with the second highest rainfall in the whole world. The precipitation in Cherrapunji is 11,777 millimeters and it receives on an average of 22,987 millimeters of rain. The northeast monsoons, which bring in moisture from the westerly winds, descend from the Himalayas to tropical Asia. These winds precipitate the moisture gathered from the East China Sea and bring them past the Himalayas towards peninsular India. The northeast monsoons begins immediately after the withdrawal of the southwest monsoons and lash India's east coast, Bangladesh, Andaman Nicobar Islands, Sri Lanka and parts of western Sumatra in Indonesia. If the northeast monsoons bless South India, they also bless the north and east of Sri Lanka. The northeast monsoons move south past the equator and hit the southeast coast of Africa by January end, heralding the monsoons in southern Africa. After dumping the moisture from the clouds on southern Africa, the ocean currents swirl up more moisture in early March and the westerlies start their northeastward motion again. By 11th April, the showers are due on Buddhist New Year in Sri Lanka, and exactly a week later, pre-monsoon showers and thunderstorms start making their presence felt on the islands of Lakshadweep and extreme southwest coast of Kerala in India. The complete agricultural cycle in the entire subcontinent as well as in tropical Asia is synchronous to the arrival and withdrawal of monsoons. This agricultural cycle comprises of sowing, husbanding, growing, harvesting, shipment, procurement and marketing of agricultural produce. The seasons are also in synchronicity to the heritage of traditions in the entire region of tropical Asia. The onset of monsoons coincides with the Buddhist New Year in April in Sri Lanka. The long-suffering people, challenged to come to terms with the heat and humidity, eagerly await the rains that virtually chases the heat away. But a strange kind of humidity then settles on the island nation, beckoning the tired souls to a rewarding breath of crisp, fresh air in the highlands. The monsoon period of April and May are awash in festivities in Sri Lanka. The Buddhist New Year is followed by Vesakh Poya, Buddha Jayanti, many other festivities associated with the life and times of the learned Buddha, and Posun Poya. It synchronizes with the beautiful offerings that Mother Nature bestows on the people of Sri Lanka during the monsoons. When the monsoon clouds hit the highlands of Sri Lanka, or for that matter Thailand, Laos or Vietnam, the clouds unpack their moisture and precipitate the humidity. The result is a grand and colorful enrichment of the earthen bounty. The humid air moistens, facilitating the blooming of orchids, flowers and varieties of rice. Rice seems the most natural crop in the water-retaining red soil types of Thailand. Similarly, in Sri Lanka, the humidity and moisture together combine the greatest soil enrichment, even in the thin mountain air, supporting the surplus growth and trade of tea. The phenomenon of monsoons around the Indian Ocean. The ocean currents and the winds carried by monsoon clouds, wind cycles and terrain around the Indian Ocean are all very significant factors in the monsoon cycle. The Hindi word mausam comes from the Arabic mausim, meaning season. No other part of the earth is as dependent on the monsoon as the Indian subcontinent and the Indian Ocean rim countries of tropical Asia. Now here's an interesting read I would like to quote from. Quote, "No single element plays a more decisive role in the life of the far-flung realm of tropical Asia than the rain. On the plains of India, in parts of Myanmar, Thailand and Indonesia, where it is dry and dusty for half the year, men, plants and animals build their lives around the expectation of the seasonal rains, and when they come in walls of towering clouds and change the landscape from seared brown to verdant green, from parched riverbed to a raging torrent. In other parts of tropical Asia, from the Malay Peninsula southwards and southeastward through the great arc of the Indonesian islands, steady rain throughout most of the year has shaped the flora and fauna up to the highest mountain ridges," unquote, says Dylan Ripley in the chapter When Rains Come in the book Tropical Asia by Life Nature Library. There is a regularity to the monsoon winds which has long fascinated meteorologists. Even today, the challenging question remains just how they blow at the anointed times and in the manner that they do. Basically, the monsoon winds arise from low pressure areas created by the heat of the sun in tropical regions. Where pressures are low, air from surrounding areas moves in, and these movements are felt as winds. In Southeast Asia, this weather machine is peculiarly affected by the differential heating between land mass and ocean. Asia is the largest of the world's land masses, and in summer the sun, blazing down on its arid interior, warms the earth to such torrid extremes that the equatorial low pressure system moves northward towards the Tropic of Cancer. This now becomes the dominant low for the season, drawing in increasing air masses from surrounding regions, and the air that pours in from the south is saturated with moisture drawn up from the southern seas. All along the island arc of Indonesia and over the Indian plains, this air moving towards the heart of Asia releases its burden as rain. It is when we document and research this yearly phenomenon that we can precisely understand the weather patterns and make sense of the larger global climate change cycles. The far reaches of tropical Asia, the thousands of kilometers of mainland ranging from India through South China, are dissected by alternating ranges of hills and mountains interspersed with stretches of plains and huge watercourses. An example is northern Myanmar. More than 1,000 miles north of the Andaman Sea, up the Irrawaddy River, lies Myat, Kenya, at an altitude of less than 180 meters or 600 feet above mean sea level, with a humid 29.4 degrees centigrade average temperature, and yet within a distance of 40 kilometers as the crow flies, mountains rise over 2,400 meters or 8,000 feet. Here, snow falls in the winter at elevations as low as 6,000 feet or 1,800 meters above mean sea level. One day, the Irrawaddy will probably wipe the town of Myat, Kenya off the face of the earth. At lower waters, the river is 555 meters wide on an average, with a gentle current. In monsoons, the flash floods increase its volume to over 900 meters width on an average. The river may rise by over 30 feet or 9 meters, and the current exceeds 8 kilometers or 5 miles per hour. Huge trees float off downstream, bridges and ferries are carried away. Occasionally, dikes are breached and low-lying cropland destroyed, villages are washed away, and carcasses of cattle and even elephants float downstream. During every monsoon season, dozens of huge rivers across southern Asia are similarly in spate, wreaking death and destruction over low-lying floodplains. The challenge to climate in Asia, climate change and Asia. Towards the end of the 20th century, man has been engaged with the challenge of human-induced or anthropogenic acceleration of climate change. Since a large part of tropical Asia is plagued by deficient development quotient, the industrial growth has been actually aided by politico-economic mechanisms. Industrial growth offers vast employment opportunities, export potential, and trickle-down effect of economic growth. Economic growth facilitates higher standard of living and a salvation from poverty that plagues the Asian continent so much. Industrial growth has meant higher production, higher consumption of raw materials and natural resources, higher employment rates, increase in consumption patterns, and a higher standard of living. But the flip side of high economic growth is air pollution, increasing urban congestion, slums, acute water shortage, wide disparities between the rich and the poor, increase in urban crime and decay. Traffic snarls in urban areas are another source for the 21st century vicious circle. More economic power and higher consumption means more cars and private vehicles. More vehicles means more fossil fuel usage and need for more roads. Lesser number of public transport vehicles is another irony. More roads means cutting more trees and more utilization of urban spaces for vehicular traffic. More vehicles on the increasing width of roads means there is lesser space for both human beings and urban greenery. that increases pollution and expedites climate change due to global warming. Global warming is having deleterious and catastrophic consequences on wildlife, forests and biodiversity reserves, agricultural production, mean temperatures in different regions, monsoon and rainfall patterns. Winters are becoming either extremely harsh or completely washed out. Similarly, there appears to be a sea change in mean summer temperatures in many parts of the world. While floods are increasing, there are also droughts. Snowfall was recorded in the most unlikely of places in 2010 in Egypt. Climate change is heralding an era which will change crop patterns and food consumption patterns. Food riots led to regime change in the Arab world in early 2011. China and India are the countries that are pushing the vestiges of climate change, justifying the thrust on 9 to 15% economic growth. China is constructing one new thermal power plant per week. Thermal energy and all other sources of carbon monoxide emissions are contributing to global warming, heralding climate change. It is expected that the global climate will be significantly warmer by 2050. Igniting the planet is the fossil fuel emissions and all other sources of emissions: cooking stoves, refrigerators, air conditioning machines, all mechanized engines, even the carbon that obtains from organic decay fuel global warming. Average temperatures will increase by 5 to 7 degrees centigrade in the tropics, it has been predicted. Carbon monoxide emissions from vehicular congestion in Asia's vast urban slums, industrial chimneys, thermal power plants, wrongful utilization of heat-generating appliances have all contributed to marked increase in average temperatures both in the atmosphere and in the ocean currents. This has led to climate change, noticeable variations in mean summer and winter temperatures, and a marked difference in the monsoon patterns. In fact, the increase and intensity of floods and droughts has had such a drastic impact on food production that the increase in price of food grains and agricultural production has led to food riots, spiraling inflation, and has started heralding a socio-economic and political revolution. It led to regime change in the Arab world. The harsh changes in monsoon and rainfall patterns have led to a rethink on the cyclical or repetitive process of climate change. Insufficient research has gone into the phenomenon of El Niño and La Niña. The currents of El Niño and La Niña have literally brought about sea change in the monsoon drift, affecting the weather pattern in tropical Asia, Australasia, and South America. The cyclical occurrences of both El Niño and its corollary, the La Niña, are, as of now, still under-researched. If the cyclical patterns of El Niño, La Niña and climate change are well researched and documented, the least we can do is prepare for the ecological disaster coming. Repercussions of El Niño and La Niña in Asia. El Niño is characterized by unusually warm ocean currents in the equatorial Pacific, as opposed to La Niña, which is characterized by unusually cold ocean temperatures in the equatorial Pacific. Quote, El Niño is a disruption of the ocean atmosphere system in the tropical Pacific, having important consequences for weather and climate around the globe, unquote, according to the website of the National Oceanographic and Atmospheric Administration of NASA. Nowhere is the effect of ocean currents more dramatic than along the coast of Peru in South America. The coastal plain of Peru is a 1,920 kilometers desert that is almost entirely barren. Paradoxically, the seas along the desert teem with life, forming one of the richest fishing grounds in the world. The key to this paradox is the Humboldt current. Moving north from frigid Antarctic waters, the Humboldt current churns up enormous quantities of nutrients for sea life. But where the current hugs the coast, it traps the land between its chilly waters and the Andes Mountains, which forms a moisture barrier to the east. But during normal times, the Humboldt current turns west of northern Peru, just south of the equator. The sea and land above the turn are truly equatorial in climate, warmed by a weak southerly current, the El Niño. In the southern hemisphere, anti-clockwise oscillations are normal. Once in a few years, this periodicity has not been documented precisely yet. This anti-clockwise oscillation reverses to clockwise oscillation, stemming from the Southern Ocean to the east coast of Australia, New Zealand, and traveling north till the equator before turning east towards the west coast of Peru. This then is the El Niño reverse oscillation. Remember, reverse in the southern hemisphere is clockwise oscillation. For reasons that scientists do not fully understand as yet, the Humboldt current sometimes starts its turn further down the coast, permitting El Niño to flow farther south than usual. And suddenly the desert comes to life. Scientists are still documenting the periodicity of the reverse oscillation, but it appears to occur once in every 4 or 7 or 11 years. The effect of each El Niño reverse oscillation lasts for about 12 to 15 months. Thereafter, the La Niña, which can also appear at infrequent intervals, may appear immediately after the restoration of the ENSO or after a gap. When it does, El Niño ushers in a sea change of weather patterns. The winds that are powered by the ocean currents, pushed or heaved by the reverse oscillation, carry far into the various continental land masses. While El Niño is the humidifying effect, its corollary, the La Niña, epitomizes the cooling effect of the winds and westerlies affected by the reverse oscillation and ocean currents. El Niño, being the warm current, unburdens the moisture condensed from heat islands and warming atmosphere in its path and accounts for increase in ambient temperatures. Droughts and floods are more accentuated. Winters are either washed out or summers become intolerably hot. These accentuated changes are visible in the normally mild tropics, thus marking a major change in weather patterns in the tropics. Among these consequences is increased rainfall across the southern tier of the United States and in Peru, which has caused destructive flooding and drought in the western Pacific, sometimes associated with devastating bushfires in Australia. Observations of conditions in the tropical Pacific are considered essential for the prediction of short-term, that is a few months to a 1 year, climate variations. El Niño South oscillation is followed intermittently by La Niña, which cools the planet inversely proportionate to the degree of warmth ushered in by ENSO. La Niña empties the cool air and moisture gathered by the current in cooler climes. It's a case in point to prove how nature balances herself for our benefit. The cool current of La Niña is responsible for a severe cooling of the planet, with hyper-cold winters even in places which are humid. Summers are also mild during La Niña period. The quantum of rainfall is unusually high in the La Niña years. When El Niño South oscillation unleashes droughts, La Niña brings in floods, wreaking sheer havoc on the agricultural production, soil fertility, ecosystem conservation, human society, economy, and civilization itself. For a deeper understanding of the repercussions of El Niño South oscillation, you may wish to study this link of National Oceanographic and Atmospheric Administration (NOAA). We are still at a nascent stage of understanding El Niño South oscillation. It is only after understanding El Niño South oscillation or ENSO that we can get a clearer insight into climate change. Dear students, now that we have understood Asia's terrain patterns, rivers and their drainage patterns, natural vegetation and ecosystems, ethnic composition, demographic patterns, traditional vocations, weather patterns and climate, we should be able to get a clearer picture of agricultural patterns. So, in the next chapter, we will learn about agriculture, horticulture, floriculture and fisheries in Asia. Please do ensure you catch us again for the next lecture. Until then, take care.